Welcome back to the programming language series where we're going to build a statically typed and JIT compiled language using nothing but Python and LLVM Lite. So today what you see on screen is what we're going to be able to compile, parse, and Lex by the end of this video. This is variable declarations. So we're going to be able to define variables using our dynamic syntax as well that I mentioned at the start of this series. So we have the first one, which is just a normal let statement, kind of has a little Pythonic typing to it, and a semicolon to signify the end of a statement. And then we have our GenZ syntax, which is let b int b 15 right now. So let maps to the let token, b maps to equals, and rn right now maps to the semicolon. So you can mix and match this if you want. So let k is an integer equals 3 right now. So you can mix and match, have the equals in there. You can do everything perfect, but screw semicolons, slap an rn, change this to anything you like. We're going to get into that right now. The first place we're going to go is, I just basically, if you're following along exactly what I'm doing, I got rid of all the test files and just have a test.lime file that we're going to be working in now. In the main.py file, I just changed this right here to test.lime, and we can get straight into token. So token.py, we're going to add a bunch of tokens and a couple dictionaries and one function into here just to help us out. So let's get started. For the first thing that we're going to do is we're going to add the let token. So we're going to add a new keywords, and we're going to have let equals let. After that, we're going to add another section down here for typing, and we're just going to set a type token. Type equals type. We need to go up to these data types, and we're going to do an ident. This is for identifiers, so pretty much the names of things. So C is an identifier, D, A, B. Save that. We'll go down to the semicolon, and we're going to do a colon. This is for our signifying a type. We're going to do our equals, which will be, we'll make a section for assignment symbols. We'll do EQ for equals, and that should be it for the tokens or the token types. So we'll go down below the token class and we'll start to create our dictionaries. So keywords, this will be of a type with a string key and a token type value. Let me change the zoom on that. If you guys want it zoomed in as much as it just was, let me know, but this is how I've been doing it for the rest of the series. So keywords, open that dictionary. The only keyword we're going to put in here for now is the let keyword. Token type.let. Now this is up for your imaginary or your imagination. These are alt keywords. They're going to be a dict, strings, and token types. So every keyword you want to map to any of your tokens, you would place in here. So the first one I want to map is lit. So token type dot let is what lit maps to. We'll do the equals sign, so b. So token type dot equal. So every time it says b, every time it sees b, it'll map to the equals token. And then right now to the semicolon. Now we'll add in our type keywords. This will be a list of strings. For right now, all we support is floats and integers, so we'll add those in there as well. We're going to have a function now, lookup ident. So the Lexer is going to call this function to see if it's a keyword, if it's an alt keyword, or if it's a type. If it's none of those, it's an identifier. So ident is a string. We'll return back a token type. TT token type or none equals keywords.get ident. If TT is not none, we want to return TT. And then we can copy and paste this and do alt keywords. And then lastly, we have our typing keywords. So if ident in type keywords, we'll return back that token type dot type. And if none of these, if it's not a keyword, it's not one of our GenZ keywords, and it's not a type keyword, we'll return back then, alright, it's got to be an identifier. Alright, now we'll head into the Lexer class. At the top, we'll go ahead and import our lookup ident function. And we need to add a couple of things to our match statement down here in next token. So underneath the parentheses, we'll do a case equals sign. And this will just be a talk equals self dot new token, token type dot EQ, and then the current character. We'll add the colon below this. So colon talk equals self dot new token, token type dot colon. We'll do self dot current character as well. Now in the default section, we'll create an if statement up here. We'll change this middle one to an elif. So if a new function we'll make underscore underscore is letter, we'll pass the current character into that. We have another function that we'll make. So literal string is self dot underscore underscore read identifier. Grab a token type from our lookup ident function. We'll pass in that literal. We'll set the token equal to self underscore underscore new token. TT equals CT. Then literal equals literal. And then we will return early that token. So now we need to implement the isLetter and read identifier functions. For the isLetter function, I will just paste this in. Feel free to pause and copy this. It's just same as kind of the isDigit, just with letters, and we also include underscores in here. So if you don't want to include that, take this or section out of it. Now we have a read identifier function. I will also copy and paste that in here just for the sake of time. This is just going to save the current position while the current character is not none and the character is a letter or it's a number. We will read the character and just keep advancing that position, and then we will return back the starting position that the function started at, and then to the newest position that we're at currently in the source, and that will return back the entire word or identifier. Alright, now that we have the Lexer pretty much ready to go for variables, let's go into main.py really quick. We will turn everything off. We'll set the Lexer to true, and we'll just check the, let me cd into this. Let's check to see if it works. So Python main.py. So we do get a bunch of parser errors, but we expect that. So let's just do, so let ident a, there's a colon, then type of integer equals 10, then semicolon. So even for here, so we have, oh, I just got lost. So we have equals right here to B. We have semicolon right here to right now. So that's how they're being mapped. And also with the lit as well. It's also a let token. So now we verified that, we can go into our AST. So pulling up our AST, we need to add 2 different nodes and node types. First one we're going to add is the let statement. Null equal to let statement. Next one we're going to add is for our identifiers, so they're literals. So identifier literal. Identifier literal. We'll start with the let statement first. So class let statement. Statement. Get the not that function. We're getting the init function. It's going to take in a name, which will be a identifier literal, but we're going to set the parent class as the type, so expression. So the value will also be in expression, and then a value type. This is something we won't really use until later down the line, but we'll go ahead and add it just for funsies. We'll add in all of these self.property initializations things. We'll go ahead and add in our type and JSON functions. Just for the sake of time, I'm not going to type these out. But same as everything else, we set the type function to our let statement, and then we have just the debug JSON pulled out for each one of our variables or our properties on this class. Next one we're going to do is the identifier literal. They are the exact same thing to integer and float, except the identifier, everything's just going to be a string, and the node type is going to be identifier literal. Exact same thing as float and integers. Now we'll move on into the parser. So in the parser, we want to go ahead and import what we just did. So identifier literal, and in our statements, we'll do a let statement. There's one helper function we need to implement before we do anything else, and that is current token is. So def current token is self tt token type turns back a bool, and it's the exact same function as the peak token, except we'll use the current token's type to see if that is equal to the one that was passed in. So doing that, now we can move on to the parse statement function. We'll scroll down till we find that. So as of right now, all we have in here is just basically moving down into the expression statements. We're going to control X this out, and we're going to create a match statement. So match self.currentToken.type. So based on the current token's type, we're going to do call other visit methods. So token type dot let, which is the one we just implemented. We want to return a self dot underscore underscore parse let statement. And then for our default case, we will just paste back in our parse expression statement. So our functions, everything else, every kind of a statement will add on to this match case statement. And if it's not a normal statement, we'll move into the expressions. So we'll move on to the parse let statement function, which I'll slap in just right under here. So def parse let statement self. We'll return back a let statement. And we got a lot of things going on in here. So just as a reminder, we'll put a let a integer equals 10. So this is what we're trying to parse. So when we found the token type of let up here, that is the token we're on currently. So the let token is where the parser is at this exact moment. So we'll first start off with getting our let statement class initialized. So the next token that we're expecting to see after this let is an identifier, so this A. So if not, self dot underscore expect peak. Oh, if I can type, expect peak. We're expecting an identifier. If we don't find it, we just want to return none. Get out of there. We'll go ahead and copy this for later because we're going to be doing this specific block of code a few times in this function. So we'll set the statement.name, now that we're at the identifier token, to an identifier literal, and the value will be the self.currentToken.literal. So now that we expect peak, this function automatically advances the parser, grabs the next token. So after we're expecting an identifier, after this is called, we know we're at an identifier token. So that's where we can get that literal. So we're going to do this if statement again. we're now expecting a colon after the identifier. So this is kind of syntax checking. After that, we're going to do the same exact if statement. After, we're going to be expecting a type. So we expect a type token. And if we do get that type token, we're going to set the statement.value type equal to the self.currentToken.literal. We're going to do this if statement one more time. We're going to check to see if the next token in the bunch is an equals token. If it is, we're going to advance to the next token. So away from that equals, we don't need it anymore. So now we're at the 10, or whatever's on this side of the equals sign. Statement.value equals self.__ parse expression. We'll do the precedence type of the lowest value. And then this is where we're going to use the current token is function. So while not self.__ current token is token type dot semicolon and not same function current token is the end of file. We're just gonna increment the parser and grab the next tokens. So if this is a semicolon right here, this will just break off and won't even advance. Or it'll advance after the first time. Just return the statement out. That's actually it for the parser that we'll need. So we can go back into our main.py file, set the Lexer back to false, set the parser to true, go in here, run the file. We'll check our ast.json. So you can see, I'll put the test.lime over here. So our first one is let a equals 10. So let, the name is a, the value is an integer, the value of 10, and the type is int. So we can see even the GenZ syntax is also working. Same thing, value b, value is 15, type is int. Same thing for the floats as well. So we have that verified that now works. So we can move on into a brand new file that we're going to be creating, which is our environment or our symbol table. So first thing, just for typing sakes, we're going to do from LLVM Lite, import IR. Do a class environment. We'll do a __ initialize method in our self. First thing we're going to pass in is records. It's going to be a little weird. It's going to be a dictionary, a string key. The value will be a tuple, and that tuple will be an IR value and a IR.type. So pretty much an LLVM value and an LLVM type. We'll go ahead and initialize that to none. We'll also set a parent equal to none. The parent is just going to be if this environment class, so we have the global environment, and if we have a function that has its own environment, that function's environment's parent will be the global environment. So we'll keep track of that here. That'll help with resolving variables. And the last thing we're going to do is name. We won't really use it much for right now. So we'll just initialize that to global. And for initializing all these variables, I'll just paste these in. So you can copy this, pause it and copy that. First function we're going to define is the define method. So def define. Let's take in a self. The name is string. The value is ir.value. And we'll do an underscore type as an ir.type. This will return back the string, or just basically well, actually, we'll not turn back a string. It'll return back the value. So ir.value. So in the records dictionary, at the name, we want to set that equal to value and underscore type. And then we will return the value back out of that. Next one we're going to do is the private function resolve. So this is called internally in the environment class rather than externally. So we'll give it a self, and all it will take in is a name. So what variable do we want to resolve? This will return back a tuple of ir.value, ir.type. This will have an if statement, so if the name is in the self.records, so if the name is in one of those keys, it will just return back the self.records at the name key. Elif, if it's not in our records and we do have a parent, we want to return back the self.parent.resolve function. We'll just pass in the name, so it'll just be a recursive to keep just walking up the tree to see if we can resolve this variable's value. Else, we'll just return none. So if it's not there, we can return an error later on. So we'll just have the else key as our return none. Now in the middle of here, we'll do a lookup function. So this is how we'll see if a variable or a function is already been defined in our environment. Taking a name. This will also return back that tuple, ir value, ir type. And all this will do is just call our internal resolve function at the name. And that is absolutely everything we need to do for the environment for right now. So we will move on into our compiler. Now that we're in our compiler, we're going to import from environment, import the environment class. We need to import our let statement and our identifier literal. I'm just going to segment the expressions onto their own line. We'll get rid of the statement. So let statement, now down in our literals, identifier literal. In our init method, we want to add in our environment, so self.env, so type environment. We'll just initialize it. So this will become our global environment to start with. And as we compile down, this is whatever our currently compiled scope or environment is. Now we need to go down to our compile method and add in a new match case statement. So node type dot let statement. And we'll visit let statement. We'll pass in the node. We'll scroll down to our other statements. That's just right beside this visit expression statement. So we'll do our visit let statement self, or taking a node, let statement. Won't return anything. Now the first variable we need to set up is our name. This will be a string, so our node.name. So as we remember, this is our identifier literal. The typing's a little off, so I know for a fact this will be an identifier literal every time, so I'm just going to do dot value there. So our value just going to be a generic any kind of expression. It's our node dot value. Our value type, node dot value type. And we won't really use this much right now, so we'll throw a to-do flag, implement. This is going to come in more into play when we're actually doing type checking. We will call our resolve value function, so we're going to get our value and our type equals self dot underscore underscore resolve value, node equals value. Ooh. So our node will be that expression. Before we move on to the rest of this, we do need to get into our resolve value function. And we need to add a case for our identifiers. So case node type dot identifier literal. We'll do this for IntelliSense. We'll do our pointer and a type equals self dot env dot lookup node dot value. So we'll look up whatever this name of the identifier is in our environment, and it will return back our pointer and our type. And we're going to return our self.builder, and we're going to load that variable at this specific pointer or value. and we're going to also send in our type. So this will return back the actual IR value, but this will create a load instruction as well. Another little piece of cleanup, since we're not going to use value type quite yet, let's just go ahead and get rid of it from our resolve value function. So that's all we're going to do for that. And we'll scroll back up into our let statement function. Now we're going to actually start the variable part of this. So if self.env.lookup name is none. First we're going to define and allocate the variable. So ptr pointer self.builder.alloc a. So that's going to allocate this type. So more than likely an integer 32, like for our example. It's going to allocate enough memory to hold that. We're going to store the value. So we're going to store that value at the pointer. So self.builder.store. Take the value in the PTR. Add the variable to the environment. So self.env.define name, value, and our type. Now, if this variable is already been defined in our environment, we want to do the else statement. We'll take a pointer, and we don't care about the type, so we'll set it to underscore. Self.env.lookup name. We'll do self.builder.store value and pointer. And this should technically be it for storing variables. So we'll just test it out really quick. I'll bring test.lime over here. We'll do main.py. I will go ahead and turn off the parser debug and turn on the compiler. So python main.py. We didn't get any errors, so we'll go into our debug in our IR. So let's start with this first one. Let a equals 10. So we're going to allocate an i32 or an int32. We're going to store the int of 10 at the pointer of this %2, which is where we allocated an int32 type. So for the same thing with the GenZ, we have just 0.4 as the variable name. We store 15 to that 0.4. And then the same things for these floats. So everything is working just as we intended. We can now store variables in our language and compile them to LLVM IR. In our next episode, what we're going to do is add in some function abilities with user-defined functions, and we're going to define our printf function so that we can finally start running this code and getting some type of an output from it. So thank you guys for watching. We have the Discord in the description if you want to ask any questions, have any suggestions, etc., etc. Thank you guys for watching. I will see you in episode 6.